Now as the velocity of an object changes because of the application of force, we find that the applied force produces a change in the momentum of the object. So the force that is necessary to change the momentum of an object depends upon the rate of change of momentum. So let us study now what is meant by rate of change of momentum. And this rate of change of momentum is going to help us to reach to the force equation. So now here we are going to study how to derive force equation. Once again children, derivations are very important from 9th standard onwards. You cannot just look at the derivation. Please practice the derivations again and again and again. So now let us see how to derive force equation, or let us see how to calculate the rate of change of momentum. So for this we are going to consider an object, and that object has mass m and the object is moving with initial velocity u. As we have already seen in the topic motion, initial velocity is the starting velocity, which is always denoted with u, and the final velocity is always denoted with v. Okay, so now we are going to consider an object of mass m moving with initial velocity u. Now force F is applied on the object, so the velocity of the object changes on application of force, and the velocity or the final velocity becomes v in time t. So what are we going to calculate here? Rate of change of momentum. Now if you remember, I had already mentioned that whenever we use the word rate, it means divided by time. So when we are dividing change of momentum by time, we will get rate of change of momentum. So now since we know the initial velocity of the object, we know that force is F, we know that final velocity is v, and we know that time is t. So let us calculate the initial momentum of the object. So the initial momentum of the object will be is equal to, what is the formula of momentum? P is equal to m into v, isn't it? So initial momentum, what will be the mass of the object? The mass of the object will be m, because we are considering one single object. But when we are considering the initial momentum, the initial velocity will be is equal to u. So the initial momentum of the object will be is equal to m into u. Now let's find out the final momentum of the object. So final momentum will be is equal to, again momentum is equal to mass into velocity. So mass of the object is m, final momentum we are going to calculate. So final velocity of the object is equal to v. Now if I subtract final momentum and initial momentum, I will get change in momentum. So change in momentum is equal to final momentum minus the initial momentum, that is final momentum is mv minus initial momentum is mu. So I can take m common, so we get v minus u. Now if I want to calculate, or if I want to find out rate of change of momentum, so rate of change of momentum will be is equal to m into v minus u. As I said, rate means divided by time. Okay, so rate of change of momentum will be is equal to m into, what is v minus u upon t? It is equal to a. So the rate of change of momentum is equal to mass, that is m, into, and what is this a? It is acceleration. Now according to Newton's second law, Newton says that the rate of change of momentum is directly proportional. The rate of change of momentum is directly proportional to the applied force. Okay, so I can say that force is directly proportional to the rate of change of momentum. And what is rate of change of momentum that I have got here? M into a. Is it clear? What is Newton's second law of motion? According to Newton's second law, the rate of change of momentum is directly proportional to the applied force. So applied force will in turn be directly proportional to the rate of change of momentum. So F will be proportional to rate of change of momentum is equal to m into a. So if we remove the proportionality sign, you know that we have to take a constant and let that constant be k. So k is the proportionality constant. So F will be is equal to k into ma. Now if I put k is equal to 1, I will get force is equal to mass into acceleration, where I have taken the value of k is equal to 1. So this equation, that is F is equal to m into A, this equation is called as the force equation. Now let's try to find out the units of force in the SI system and the CGS system. What is force? Force is the product of mass and acceleration, that is F is equal to m into A. Now in SI system, what is the unit of mass? Kg. In SI system, what is the unit of acceleration? Meter per second square. So the unit of force in the SI system is kg meter per second square, or kg meter per second square is also called as Newton, which is denoted by capital N. So what is the unit of force in the SI system? You can simply say it is Newton. Let's see what is the unit of force in the CGS system. In the CGS system, mass is measured in grams. The unit of acceleration is centimeter per second square. So the unit of force in the CGS system is gram centimeter per second square, or gram centimeter per second square is also called as Dyne. Now, since we know the units of force in the SI system and in the CGS system, let us define the units of force in the SI system and in the CGS system. So what is the unit of force in the SI system? Newton. And what is the unit of force in the CGS system? Dyne. So we are going to define 1 Newton and 1 Dyne. Okay. Now what is force equal to? Force is the product of mass and acceleration, isn't it? So let's define 1 Newton force. So if the force has to be 1 Newton, mass has to be 1 kg. This has to be 1 kg. This is mass. And acceleration has to be 1 meter per second square. Okay, so this is acceleration. So now how to define 1? See, 1 into 1 will be 1, and kg meter per second square is nothing but Newton. So let's define 1 Newton of force. A force which causes a mass of 1 kg to move with an acceleration of 1 meter per second square is called as 1 Newton force. So if the force has to be 1 Newton, what should be the mass of the object? 1 kg. And that object should move with an acceleration of 1 meter per second square. Then the force will be is equal to 1 Newton force. So once again, what is 1 Newton force? A force which causes a mass of 1 kg to move with an acceleration of 1 meter per second square is called as 1 Newton force. Similarly, the unit of force in the CGS the unit of force in the CGS system is Dyne. So if the force has to be 1 Dyne, mass should be 1 gram and acceleration should be 1 centimeter per second square. So this is mass. How much should be the mass? 1 gram. And the body should move with an acceleration, mass. The mass should be 1 gram and the object should move with an acceleration of 1 centimeter per second square. So we define 1 Dyne of force as a force which causes a mass of 1 gram to move with an acceleration of 1 centimeter per second square is called as 1 Dyne force. Once again, a force which causes a mass of 1 gram to move with an acceleration of 1 centimeter per second square is called as 1 Dyne force. So once again, what is 1 Newton force? The force which causes a mass of 1 kg to move with an acceleration of 1 meter per second square is called as 1 Newton force. And 1 Newton is equal to 1 kg into 1 meter per second square. 1 Dyne force, the force which causes a mass of 1 gram to move with an acceleration of 1 centimeter per second square is called as 1 Dyne force. And 1 Dyne is equal to 1 gram into 1 centimeter per second square. Let's see the relation between Newton and Dyne. Now we know that 1 Newton is equal to 1 kg into 1 meter per second square. So 1 kg means 1000 grams into 1 meter. To convert meter into centimeter, we'll have to multiply by 100. So 1 meter per second square will become 100 centimeter per second square. So 1 Newton will be is equal to 1000 grams means 10 raised to 3 grams. And 100 centimeter per second square means 10 raised to 2 centimeter per second square. So 1 Newton will be is equal to 10 raised to 3 plus 2, 5 grams centimeter per second square. And 10 raised to 5. What is gram centimeter per second square? Dyne. So what is the relation between Newton and Dyne? 1 Newton is equal to 10 raised to 5 dynes. So now let's see the statement of Newton's second law of motion. As we have already seen in the derivation of force equation that the rate of change of momentum is directly proportional to the applied force, isn't it? So what is Newton's second law of motion? The rate of change of momentum is directly proportional to the impressed force. Impressed force means applied force, and that change in momentum takes place in the direction in which the force is applied. So once again, the statement of Newton's second law of motion is the rate of change of momentum is directly proportional to the applied force or impressed force and takes place in the direction in which the force acts.